Okay, this is section 7.4, video number 2. Just 2 examples in this one. There's a couple reasons why I'm going to show this first one. Otherwise, it's not really very difficult. And then the last one will have a little bit more involved in it. And you'll see what I mean as to why I'm showing that one. Definitely the most involved of all of them. So this example right here, clearly this is already in the correct form because it's dx, which is really just like having a 1 on top. And you could slide the dx off to the right. As a matter of fact, I usually like to write this that way so that it's 1 over, as a matter of fact, let's go ahead and do all this at once. The denominator needs to be factored. It's the difference of squares, so it should be x minus a, x plus a, and then I'll put the dx off to the side. That's just where I prefer to see it, because if you don't, sometimes you forget that there's a 1 up there. It is in the correct form. The highest power is in the denominator. I've gone ahead and factored it to 2 distinct linear factors. One is x minus a, one is x plus a. So what we need to do is we need to figure out what the numerators are going to be when we separate this. So we're going to write this as 1 over x minus a, x plus a equals something over x minus a plus something over x plus a. Now, the reason I didn't write anything on top right now is because we're using lowercase a's that were given to us in the problem. So instead of using a capital A on top, I'm just going to go to the next letter, and I'm going to call it B, and then I'm going to call it C. It really doesn't make any difference what the letters are on the top as long as you keep them straight. But the only reason I'm doing that is because of the lowercase a. So again, that numerator on the left, 1, is going to equal the b times the part that it is missing, which is the x plus a, plus c multiplied by the part of the denominator that it's missing, which is the x minus a. And again, don't forget, what you're really doing there is you're multiplying both sides by the common denominator. This is just a quicker way to think of it. Now we can let x be convenient values that's going to get rid of one or the other b or c's. So I'm going to let x equal a. And if I let x equal a and plug that in over here, a minus a is 0, the c is gone. So we're going to get that 1 equals b times 2a. Right? If I plug a in for x, I get a plus a, which is 2a. Which means that b, solving for b, is 1 over 2a. Okay, we'll do the same thing. We're going to let x equal negative a, because that's going to get rid of the b variable. And so we're going to get 1 equals, if I plug the negative a into the c part, it's going to be negative a minus a, which is minus 2a, so c times negative 2a, which means that c is 1 over 2a, excuse me, negative 1 over 2a. So we have our constants. Let's go ahead and do our substitution. So we're going to get the integral now of, let's see, b was 1 over 2a over x minus a. C was negative 1 over 2a over x plus a dx. Now we can go ahead and take our integrals. Antiderivative of the first one, remember that those lowercase a's are constants. So it's going to be 1 over 2a times the natural log absolute value of x minus a. Okay, that's the first one. Minus 1 over 2a natural log absolute value x plus a plus c. And that's a perfectly acceptable answer. As a matter of fact, if this was on some kind of a free response question, that's probably how you would leave it. However, just to make sure, if this something like this, which very well could appear on a multiple choice question, shows up, it may not look like this. And the reason for that is, 1, I can factor a 1 over 2a out to the front, which would leave you with the natural log x minus a minus the natural log, excuse me, absolute value of x minus a minus the natural log absolute value of x plus a plus c. But we're still not done, because I can combine those two natural logs through subtraction, I can combine those things by condensing two natural logs. So I would get 1 over 2 minus a natural log. Now remember, when you're combining or condensing natural logs through subtraction, you divide the arguments. So it's going to be x minus a over x plus a plus c, which is certainly an acceptable answer. The other thing you could do is you could flip those. I'm not going to write this down, but you could flip the x plus a and x minus a and bring a negative sign out to the front of the 1 over 2 minus a. Most likely, this is the way it would be presented. But any one of those three things are absolutely correct. You just have to know that it could appear in this form. Okay, moving on to number 4, which is by far the more, I don't want to say difficult, it's just the lengthiest problem as far as the amount of stuff that needs to be done here. Okay, a bunch of different things are going to happen in this. First of all, if I were to see a problem like this, the first thing I notice is, 1, it's rational, and 2, it's improper. Okay, the degree on the numerator is definitely higher than the degree in the denominator, which means we need to start off with a long division. And it's a lot of terms to write, so to give yourself some room. So what goes on the outside is the denominator, x cubed minus x squared minus x plus 1. The inside is going to be x to the 4th. It's missing the cube term, so I have to put a 0x cubed. And then I think we're good from there, minus 2x squared plus 4x plus 1. Obviously, just be very careful in writing all your terms down. Ask yourself, what do you need to multiply times that first term, x cubed, to get the first term underneath, x to the 4th? Well, that's just x. It's kind of nice because that's way over here already. Now you distribute the x to everything. So x to the 4th minus x cubed minus x squared plus x, parentheses, subtract. X to the 4th minus x to the 4th, gone. 0x cubed minus minus x cubed becomes plus, so that's plus 1x cubed. Negative 2x squared minus minus, so plus x squared becomes minus x squared. 4x minus x is just 3x. And then we'll bring down the 1. All right, one more time. What do I multiply times x cubed to get x cubed? Just 1. So I'll put a 1. Multiplying the 1 through really just is going to give you the same thing. So x cubed minus x squared minus x plus 1. Parentheses, subtract. X cubed minus x cubed is 0. Negative x squared minus negative x squared is 0. 3x minus minus x is plus x, so that's going to be plus 4x, and then 1 minus 1 is 0. So my only remainder is 4x, so that gives me a plus 4x over the original denominator, x cubed minus x squared minus x plus 1. Like I said, got a bunch of work to do in this problem because that's wonderful. What it gives me is the integral of x plus 1 plus 4x over x cubed minus x squared minus x plus 1 dx. The first two terms, x and 1, the x plus 1 part, that'll be simple. Those are just straightforward power rule antiderivatives. The other part still has some work to do. I've still got to factor it. It's in the proper form now because x cubed is the highest power. 4x on the top is going to be x to the 1st, which is the highest power on the top. We're in the correct form. The highest power is in the denominator. So now it needs to be factored. Well, I've got 4 terms to factor. And in case you don't remember how to do that, the best way to factor these is to do factoring by grouping. So for this denominator, I'm going to group the first 2 terms together, and then I'm going to group the second 2 terms together. Notice I kept the negative with the x and not outside of the parentheses. It makes a huge difference. All right, so now what do we have in common in that first parentheses? It looks like I have an x squared, which will leave us with an x minus 1. The goal is to have an x minus 1 in both parentheses, and I can do that by factoring the negative 1 out of the second parentheses, which is going to give me a minus 1 times x minus 1. Now the common factor here is x minus 1, so I can factor an x minus 1 out, which leaves us with an x squared minus 1. Of course, x squared minus 1 is a difference of squares. It factors again. So what I get is x minus 1 times x plus 1, x minus 1. Now what you will notice here is that I have two factors of x minus 1. Okay, and this is going to be really important. If you have two factors which are linear, but they are not distinct linear factors, you're going to have a different situation than we've seen before. So let's go ahead and write this out. Just for this part right here, again, we're only dealing with this part right here. We are going to do our partial fraction decomposition, which means that that fraction right there is going to equal something over, I'm actually going to use the x plus 1 part first, doesn't matter which order we go in, plus something over the x minus 1, and here's the part that changes. I am going to have something, it's not going to be over x minus 1. It can't, because if that was the case, then really I could just put b plus c on top of x minus 1. It doesn't work that way. I need three distinct factors. This one gets the square. And the reason for that is because you have to include the fact that x minus 1 goes into both x minus 1 and x minus 1 squared. Okay, I know that's a little bit more challenging to see. So think about it this way. If I had a third plus a half plus a half, those are not really three things that are different, because I can add the 1/2 and the 1/2 and get 2 halves or 1 out of that. So this would actually be a third plus 1, or third plus 2 over 2. But what if it was 1/3 plus 1/2 plus 1 over 2 squared? Well, now that third one really becomes a fourth, and now you can see that I would have to multiply all three of those factors together in order to get a, well, actually not true, I would still be able to get a common denominator, but I would have three different denominators. Okay, I know that may or may not make sense to everybody, but just know that if you have non-distinct linear factors, you must include the power of however many there are. So I have two x minus 1s, so I have to have an x minus 1 squared. If I were to have four x minus 1 factors, I would have to have an x minus 1, x minus 1 squared, x minus 1 cubed, and an x minus 1 to the fourth. That would be a very long, intense problem, but just to let you know, that's what you would have to do. Okay, you most likely will not see that anywhere. All right. Now we're ready to go ahead and get rid of all the denominators. So remember, getting rid of the denominators, multiplying both sides by the common denominator will give you 4x on the left. Let's see, a is missing two of the factors. It is missing both of the x minus 1s. So the a is going to get multiplied by x minus 1 times x minus 1, or x minus 1 squared. And again, you can go from this right here if you need to say, oh, a is missing both of the x minus 1s. B is missing one of the x minus 1s and an x plus 1. So B gets x plus 1, x minus 1. And then C is only missing the x plus 1 because it has both of the x minus 1s in it already. So C is going to only get multiplied by x plus 1. Okay, let's use our method like we did before. If we let x equal, let's see, what would be a nice value? -1 would be a good value. If we let x equal -1, that's going to make that 0. It's going to make that 0. So the b and the c are going to go away. So that's going to give me -1 minus 1 is -2 squared is 4. So we're going to get 4a. Plugging in the -1 on the left gives me a -4. So a is going to be -1. All right, let's try another one. Let's let x, see what would be the other good value. A +1 looks good. If we let x equal +1, that one's going to go to 0. That one's going to go to 0, and I'll still have a c value left over. So that's going to give me 2c. And then on the left here, we're just going to get 4. So then that means c is going to equal +2. The problem is, what are we going to do about b? I've already used up -1 and +1. I can't use those again because both of them make b go away. Well, I can pick any value that I want to. Let's pick something easy. How about let's pick 0 in this case? Not always 0, but most of the time 0 is the easiest one to pick. And you might think to yourself, wait a minute, that doesn't make anything go away. You're right, it doesn't. Well, the left side, it makes it 0. But so the left side, we're going to get 0. On the right side, we do have a little bit of work to do. If I plug 0 in for x, I'm going to get negative 1 squared, which is 1, times a. But I know what a is. That's the good thing. I already know a. So we're going to get negative 1 times positive 1, which is still going to be negative 1. The b part, I still need to have that one because I got to find a value for b, and that's fine because I'm going to get, let's see, 1 times negative 1 is negative 1 times b, so it's going to be b times negative 1. And then the c, again, I know what c is, which is nice. I know that c is 2. We've already solved for it. And if I plug 0 in there, I get 1. So now I can actually solve this for b. So let's see. We're going to get negative 1 and positive 2. Negative 1 and positive 2 is going to be 1. Subtracting 1 to both sides, we get that b times negative 1 equals negative 1, which means that b is 1. So I have my a, b, and c value. So now let's go ahead and replace our integral with the a, b, and c value. So I'm going to integrate. Now we got to go back up, see what the original one was. X plus 1? Yeah, x plus 1. Don't forget that original x plus 1. Plus, let's see, a is negative 1 on top of, what did a go on top of? X plus 1. B is positive 1, and that went on top of x minus 1. And c is positive 2, and that went on top of the x minus 1 squared. Okay, like I said, a little bit more. This one's easy, this one's easy, that's become easy, that's become easy. This one right here is not linear. The denominator is not linear. You cannot use the natural log here. As a matter of fact, you're going to have to do a very simple u sub on that one right there. So let's go ahead and do our u substitution, then we can go ahead and take all the derivatives. So I'm just going to work with the 2 over x minus 1 squared part. So in that case, u is going to have to equal the x minus 1, which makes du 1 dx, or just dx. So now if I were to do my integral, it would be 2 over u squared du, which is the same thing as the integral of 2u to the negative 2 du, antiderivative. So raise the power by 1, we get u to the negative 1. Dividing by negative 1, you get negative 2. So that's the same thing as negative 2 over u. And yes, there would have to be a plus c, but this is just kind of side work because we're going to put the plus c into the actual problem. All right, so now we should have everything that we need to finish the problem. Antiderivative of x is 1/2 x squared. Antiderivative of 1 is x. Antiderivative of negative 1 over x plus 1, that is a natural log. So it's negative natural log absolute value x plus 1 plus. Antiderivative of 1 over x minus 1 is the natural log absolute value x minus 1. And then the last one we worked out on the side here, that's going to be minus 2 over u. Don't forget to put back the original u, which in this case was x minus 1. So don't forget to substitute x minus 1 back into u, and then don't forget your plus c. And that is the antiderivative of this original function way up here. So again, it looks like you might be undoing a quotient rule. It's not really undoing a quotient rule. We're really undoing logs in this case. A lot of logs mixed in with some other things, but there's going to be a lot of logarithmic stuff in here. Okay, that should be hopefully plenty enough. There might be some things that you come across, but you're just going to have to do a little bit of thinking that I didn't necessarily show, but I've showed you just about everything that you need in order to do these kind of problems.